secure hash algorithm. So in this novel, it's of 6 steps. So here in this SHA1, that is secure hash algorithm, we're going to accept a plain text. So the plain text should be of less than 2 with 64 bit. So what we are going to do is give the output of message DS, which is of 160 bit. So the SHA1 will going to accept and input a plain text which is less than 2 power of 64, and it will going to give an output in MB, that is message DS. The output will be of 160 bit. So here in this step 1, I'm going to do is in this step 1, I will going to append, or we're going to append or padded bit. So you guys know already what do you mean by a pad. That is nothing but padding. So in this step 1, I'm going to add the bit in such a way that padding bit should be a multiple of 512. So that is multiple of 512 means 512 multiple into 1 will be 512. 512 multiple into 2 is 1024. Like this, the padding which should be a multiple of 512. So if you are computer network that is in cycling redundancy check algorithm, we are using padding bits simply as zeros. Whereas in SHA1 algorithm, we are going to pad 1 followed by the remaining zeros. So one more condition in this SHA1 is, so here we need to add 448 bits up to 448 bit, and if I mode 512, well, it should go into 64. So this is the main in 64 bit. So that means if a message consisting of suppose around 300, I need to add 148 bit more in order to make 448, and we should remain 64 bit. So in step 2, what we're going to do is we're going to pad the length. That is the padding length. So the remaining 64 bit, what we have left out, we're going to use. So 64 plus 448, which you're going to make 512. To first step, we're going to append a padding bit so such a way that it should be equal to 448, and the remaining 64 bit we are going to append in my step 2, that is has a padding length. So totally put together we will going to make 512.
Step 3. Prepare processing functions. SHA1 requires 80 processing functions defined as: first, F T B C D equal to B and C, or not B and D. So 0 is less than equal to T, less than equal to 19. Next, F T B C D equal to B SOR C SOR D. So 20 is less than equal to T, less than equal to 39. Next, F T B C D equal to B and C, or B and D, or C and D. So 40 less than equal to T, less than equal to 39. And the last one is F T B C D equal to B SOR C SOR D. So 60 less than equal to T, less than equal to 79.
Step 3. Prepare processing function. SHA1 requires 80 processing function defined as T, B, C, D equals to B and C or not B, and D 0 less than equal to T less than equal to 19. T, B, C, D, B XOR C XOR 20 less than T equals to 39. T, B, C, D equals to B and C or B and T, or C and 40 less than T less than 59. T, B, C, D, Bx equals to Bx OR C XOR D 60 less than equals to T less than equals to 79.
SHA or SHA1 framework contains Step 5. Initialize buffers. SHA1 requires 160 bits or 5 buffers of works 32 bits. HO equals 0 times 6, 7, 4, 5, 2, 3, 0, 1. H1 is equals to 0 times E, FC, DA, B8, 9. H2 equals 0 times 9, 8, BA, D, C, FE. Then the H3 is equal to 0 times 1, 0, 3, 5, 2, 4, 7, 6. Then the last is H4 is equals to 0 times C, 3, D, 2, E1, F0.
Step 6. Processing message in 512 bits blocks. L blocks in total number. Step 6 is the main task of SHA1, which look through the appended and pended message in 512-bit blocks. We have input and predefined function. M, closing open brackets is 1, 2, to reach the letter L is the block of the pended and appended message. F, closing open parenthesis 0 semicolon, B, comma, C, comma, D, and F, closing open parenthesis 1 semicolon, B, comma, C, comma, D, comma, to reach the F, closing open parenthesis 79 semicolon, B, comma, C, comma, D is the 80 processing functions. K, closing open parenthesis 0, comma, K, closing open parenthesis 1, comma, and to reach the K, closing open parenthesis 79 is the 80 processing constant words. H0, H1, H2, H3, H4, H5 is the 5-word buffet with initial value. Here is the pseudo code. This is the output. H0, H1, H2, H3, H4, H5 is the word buffer with final message digest.